Alright, we'll continue with part D. We're looking for the time between 0 and 12 hours at which the volume of heating oil in the tank is at its least. And we want to show the analysis that leads to our conclusion. Alright, so we're talking about a minimum here. And once again, because we have a continuous function on a closed interval, therefore the extreme value theorem tells us there has to be an absolute minimum. And furthermore, it has to occur at a critical value or an endpoint. So we're going to make a table of values, and we've already calculated, or we're given the value at time t equals 0, that's 125, and we've just calculated the value at 12, and that's 122.026. So those are our endpoints. We still need to check for critical values of L of t. So I'm going to spend a few minutes to look at the function, get a graphing window for it. And once again, what we're looking at is L of t, which turns out to be 125 plus the integral of y1 minus y2, or e of t, h of t minus r of t here. And we know that the derivative L prime of t is just y1 minus y2. So what I want to do here is I want to graph y1 minus y2, and I want to find out where the critical values are. So I'm going to set my viewing window from 0 to 12 for x in steps of 1, and then for my y values I'm just going to make those negative 20 to positive 20 by 2's and see how that comes out. When I go to graph it, I can basically see everything that I need there. The first critical value is going to be a relative maximum, so that's not going to be important, and the second will be a relative minimum, which will be important. So I want to find the values of those critical points, the x values, the t values of those critical points, and I'm going to find them using the zero function. Second, calc, option 2, left bound 0, right bound 6, should give me the first one, guess, and that is at 4.79. However, we do know that that's a relative max. So I can just say that I know that a relative max can never be an absolute min, and so therefore I don't need to worry about its value. The second one, second, calc, I'm looking for a 0 again, this time from 6 to 12, and my guess is going to give me 11.318. And I'm going to store that value, which is an x value, go out to the main screen, and I can say x store alpha a, and that's the 11.318. I go back to my graph, and I want the integral, option 7, from 0 to alpha a. And remember, that's going to give me the net change in level over the 12 over the 11.318 hours, and so that's negative 4.262. I want to add that to 125, and I end up with 120.738. And you can see there that that is the lowest point of all of the critical values and endpoints that I have there. So I'll label that as my absolute min and record that that happens at t equals 11.318. And we're all set with problem number 4 then.